Greetings, hello, welcome. Let's talk about sketching rational functions. Okay, sketching rational functions. Okay, let's say we're given a couple of functions. The first function looks like this. F of x is equals to 1 over x, and you're asked to sketch this. Let's say a friend asks you to sketch this. The second one would look like g of x is equals to what is 3x divided by x minus 1. Okay, third one, let's let's call it h of x. H of x is equal to 2x plus 1 over x plus 1. 2x plus 1 divided by x plus 1. Okay, so for this, well, let's plot these ones for now. These are enough for now. Let's sketch them, I mean. Okay, so let's sketch the first one. Now what's the first thing we need to do in order to sketch a rational function? Now, as you can all see, that these functions each have a denominator, which is the lower part, and they have a numerator, which is the upper part. So they have a numerator and a denominator. They're all fractions of polynomials. Just mentioning that a rational function contains a numerator and a denominator. Okay, cool. Alright, so what do we need in order to sketch such a graph? Alright, so in order to sketch this graph, we need to know certain points. The first thing that we need to know is we need to know the vertical asymptote. We need to know the location of the vertical asymptote. Of the graph, so we'll call it VA for short. So we need to know where the vertical asymptote is located. We also need to know where the horizontal asymptote is located. What else do we need to know? We need to know X-intercept. Just call it XI. X-intercept. Okay, X-intercept. Normally your y is always 0 at this point. We need to know that point. We also need to know the y-intercept. You find y when x is 0. In this case, x is always 0. need to know y-intercept and x-intercept. So these are the four key points that we need to know in order to be able to plot a rational function, any rational function. Okay. Sometimes you'll find that it will be necessary to just get some few extra points on the side of the asymptotes, but then we'll look at that later. So for now, let's plot this one. All right, we'll make some room here. P of x is equals to 1 over x. Okay, so how do we find the vertical asymptote? So number one, let's find the vertical asymptote, VA. If you want to find the vertical asymptote, we equate the denominator to 0. So in this case, we'll equate x is equals to 0. By equating the denominator, then we are then able to solve for the values of x, and then in turn be able to get those values for x. The values we get for x will tell us or will inform us of the location of the vertical asymptote. In this case, the value for x, just that x is equals to 0. So the vertical asymptote lies at x is equals to 0. Okay, what about the horizontal asymptote? Okay, for the horizontal asymptote, we need to observe or look at our function. We need to look at the degree of our numerator and the degree of our denominator. So looking at our case, we see that the degree of our denominator is greater than that of the numerator, greater than that of the numerator, which is x is equals to 0. Therefore, the horizontal asymptote will lie at y is equals to 0 always if the denominator is polynomial's degree is greater than that of the numerator. It always lie at the horizontal asymptote will always be at y is equals to 0. Alright, cool. What else? Let's find x-intercept. So the x-intercept is found when y is 0. So when f of x is equals to 0, let's quickly find that. So 0 is equals to 1 over x. Okay, so we'll see here there is no. Okay, let's just finish it off. Okay, move this guy that side. So that's x multiplied by 0 equals to 1. So x equals to 1 over 0, that is. Now x times 0, what am I doing? This is so wrong. This is, yeah, if just already x times 0 it's only which is 0, so 1 divided by 0, infinity. It cannot be the x-intercept. Or could it be? Perhaps it is. We'll see. X-intercept is at infinity. Okay. When y is 0, x is at infinity. Okay. Cool. Let's see where that takes us. Interesting. Alright, let's look at the y-intercept. Y-intercept, x is 0, want to find out what is y. Okay, so f of x is the same thing as y, which is equals to 1 over 0. Therefore we have 1 over 0 undefined on the calculator. Cannot divide by 0, so 0 is at infinity. Ooh, cool stuff. Okay. All right. So let's plot this graph. Let's plot the graph. Okay. So we have vertical asymptote. Asymptote at x is equals to 0, and just plot that. Okay. Yeah, I'm just drawing our grid here. So at x is equals to 0, we'll have our asymptote. So x asymptote will be exactly at the origin point of 0, 0. So that's where our vertical asymptote is, at x equals to 0. This is why x is 0. Right. So horizontal asymptote is found to be at y is equals to 0. Alright, so horizontal asymptote is also is also uh, at the origin. This is cool. Nice. Okay. So let's move on. X-intercept. X-intercept was found that when y0 x what the graph will intersect the horizontal axis at infinity. At infinity. At infinity. That's when y is 0. And for the y-intercept, well, same story. When x is 0, the graph will only intersect the y-axis at positive infinity. Okay, I need to draw this now. Need to sketch it. Okay, so vertical asymptote tells me this graph can either be there, or it could be here. It could be in the fourth quadrant, or it could be in the first quadrant. Then how do I know where the graph is? How do I know where to plot the graph? Okay, we'll look at our x-intercept. What does it tell us? It tells us that when y is 0, at that point, when y is 0, our x-intercept will be where? Is towards positive infinity. Toward positive infinity. So the graph is going that direction. So that is telling us that our graph is going that direction. So, and then it's going that direction, could either be, so that means it's either in the fourth quadrant or in the first quadrant. But how do I know which quadrant it is located in? Is my graph located in? That's okay. So the x-intercept has told us that it's in, the graph is approaching 0 or the x horizontal x-axis as it approaches infinity, at infinity. So what are we being told by y-intercept? Well, y-intercept tells us that when x is 0, um, well, the graph, which is f of x, approaches the y-axis at infinity. So at positive infinity, not negative infinity. So a graph will be going that direction. Ha, cool. So right from here, exactly from here, we can be able to tell that our graph will be in the first quadrant. Be like that. Let me just draw it nicely. Take this off. Oh, come on. Okay, there we go. So we'll have a graph approaching the asymptote as the horizontal axis approaches infinity. In some story, it will approach the vertical asymptote as well as the vertical asymptote approaches infinity. Okay. Okay. Is this an odd or even graph? Look at that letter. For now, what about negative infinity? That one is sorted. So we have reflection in this direction. But how sure am I that the second portion belongs in the third quadrant? We need to prove this. Need to prove this. I can just write that. So to do that, I will need points. Let me get some points, set of points from this side. We need points. Let me say minus 10, minus 10, minus 5, minus 20. Okay, so let's find out what is f of x when x is minus 5. Well, the graph is 1 over x, so when x is minus 5, the graph is minus 1 over 5. Yep. Okay. Minus 1 over 5. This is the same thing as minus, okay, let's do the division, negative 0 point, add a 0 there, add a 0 there, and then we'll have 10 divided by minus 5, that's 2. So 0.2, somewhere there. 0.2. Okay, divided minus. Okay, let's try what is x or y at minus 1. It will be 1 over negative 1, which will give me negative 1. So what this is telling me, this point is there, negative 1, negative 1. As graph approaches 0, see that the graph is increasing as approaches infinity. What about 0.1? What about 1 divided by negative 0.1? Well, we'll get something like minus 10. So you see, so there's no doubt the other portion belongs in the third quadrant. Okay, let's get rid of that. Let's get rid of this. Okay, so it's a reflection, the origin, reflection of a drawn graph. Well, it's not a reflection, it's an odd function. Therefore, we are rotating that drawn graph by 180 degrees. This one rotated by 180 degrees, the original art, and then we'll be able to have, okay, so our graph will be like this, to look something like this. All right, okay, I think that's pretty much brings this video to a close. I'm back for come back the following video, so we finish plotting the other asymptotes. All right, cool.